Welcome to Math 2318. This is section 5.5. We enter a different realm today in 5.5 in that now we are considering C2, the complex plane. So we want to find complex eigenvalues and complex valued bases. So let's see, here's matrix A. So I find the determinant of A minus lambda I, just like normal, set it equal to 0. So downward diagonal minus a minus 26. All right, so grinding this out term by term and simplifying, we get lambda squared minus 12 lambda plus 37 is 0. This is not factorable, but we have the quadratic formula. All right, so let's see. Minus b plus or minus the b term squared minus 4 times a times c, all divided by 2 times a. So we get 144 minus 148, so a negative 4 square root. So that's going to give me a 2i. So splitting this up, 12 over 2 is 6, 2 over 2 is 1. So we get two eigenvalues. They are 6 plus I and 6 minus I. So how do we go about finding the eigenvectors? Well, the same way as before. I find a minus lambda 1I. So here's a minus 6 plus I, 6 plus I. So my complex values in the matrix. 1 minus 6 is a minus 5 and a minus I. 11 minus 6 is 5 minus I. And so now we have our matrix with complex values. We're going to do row operations. I see there's a 1, so now I'm going to use this 1 to make a 0 underneath it. Well, I need all of this to cancel, so I'm going to multiply row 1 by 5 plus I all the way across and add it to row 2. Okay, multiplying it by 1 is easy. Here it is multiplied by 5 minus I. Alright, so when I add up these two, I get 0. I get nothing from the end. What about this part? Well, let's see. 5 times 5 is 25. Because of the plus and minus, there's no middle term. So I get a minus I squared. But I times I, or I squared, is minus 1. Alright, so I've got 25 minus a minus 1, making it 26. 26 minus 26 is 0. And so we get a row of zeros which says x2 is free, x1 is minus 5 plus I times x2. So for lambda being 6 plus I, we get our basis vector here of minus 5 plus I and a 1. Now if we repeat this process for 6 minus I, same process all the way through. I've got a 1, so I'm going to swap out and put row 2 on the top. Now I'd like to use this 1 to get rid of the stuff underneath it. So I'm going to need a 5 minus I all the way across. Well, again, these cancel and I get a 0. 5 times 5 is 25 minus I squared minus 26. But I squared is minus 1, so I really get 26 minus 26 is 0. So x2 is free and x1 is minus 5 minus I times x2. And so I get minus 5 minus I and a 1. And this is my basis for my second eigenvalue, which is 6 plus I. All right. What about this particular matrix? We've got 1 minus 26 and 1 and 11. All right. So that's where they were showing us how to do it. That's where we had before. Okay. In question 2, we have a new matrix, 2, 1, minus 20, and 10. I form the determinant of A minus lambda I. All right, and so get that determinant, that downward diagonal, minus a minus 20 equals 0. So grinding this out term by term, and then cleaning it up, we get lambda squared minus 12 lambda plus 40 is 0. Alright, so I get 12 plus or minus 144 minus 160 all over 2. Well, let's see, 144 minus 160 is minus 16, so I get a 4i. So 12 over 2 is 6, 4 over 2 is 2. So my two eigenvalues are 6 plus 2i and 6 minus 2i. Alright, well, what about the eigenvectors? So I need to form A minus 6 plus 2i. Alright, so 6 plus 2i. On the diagonals, 2 minus 6 is a minus 4 minus 2i. 10 minus 6 is 4 minus 2i. Alright, so now I need to solve this to find the corresponding eigenvector. Alright, well, let's see. I'm going to take row 2 because I've got a number here. I'm going to divide through by minus 20, so I get a 1. 4 over minus 20 is a minus 1/5. A minus 2 over a minus 20 is a plus 1/10. Alright, so now I'm going to use the 1 to make a 0. Well, I'm going to need a 4 plus 2i, multiplied all the way across by row 1. Alright, so I add that to my row 2. This is a 0. What about all this stuff? Well, let's see. From this to this, I get a minus 4/5. For this part, I get a plus 2/5 I. I get a minus 2/5 I, so those two terms will cancel. And I get a 2/10 or 1/5 I squared. So I've got a minus 4/5 and a minus 1/5, which is a minus 5/5. So minus 1 plus 1 is 0. And I get that x2 is free, and so I can figure out what x1 is. So simply move all of that to the right. And so to get my basis, it's x2 times 1/5 minus 1/10 I and a 1. Now you can leave it like that, or what I would have done is multiplied through by 10 just to get rid of the fractions. So I've got a 10 on the bottom. 10 times 1/5 is 2, so 2 minus I and 10. Or you can multiply it by 20. Not sure why they did, but they did. And they left the answer in this format. Alright, what about for the other eigenvector? So A minus 6 minus 2i. So fill that in along the diagonals, perform the subtraction. Again, I'm going to use this minus 20. So swap the rows and divide by minus 20. Alright, so I've got a 1 here. I now will use this 1 to make a 0 under it. Alright, so I'm going to need a 4 minus 2i all the way across times row 1. Alright, well, again, what happens? Well, let's see. These will cancel, giving me 0. I've got a minus 4/5, a minus 2/5 I. I've got a plus 2/5 I, so those two cancel. And I get a minus 1/5 I squared. So again, I get a minus 4/5, minus 1/5, so a minus 5/5 plus 1, which is 0. And so I get x2 is free, and x1 then is 1/5 plus 1/10 I x2. Filling that in a vector column format here. So again, I can multiply through by 10 and get 2 plus I over 10, or you could multiply through by 20 and you get this basis vector for that particular eigenvalue. Okay. All right, in question 3, we have new matrix A. I want to form the determinant of A minus lambda I, set it equal to 0. All right, downward diagonal minus a minus 9, clean it up. Lambda squared minus 6 lambda plus 18 is 0. We need to use the quadratic formula. 4 times 18 is 72. 36 minus 72 is a minus 36. Square root of minus 36 is 6i, so divide everything by 3. And so I get my two eigenvalues of 3 plus 3i, 3 minus 3i. Okay, so we try to find our eigenvectors. Alright, so a minus 3 plus 3i times I. Alright, so that's there. 3 minus 3 plus 3i, I get a minus 3i. Same thing on this one. Alright, so I see I can get a 1 there, so swap out row 1 and row 2 and divide by 3. Alright, so if I multiply this row by 3i and then add, okay, 3i, these will cancel. A 3i times a minus I is a minus 3i squared, which is a positive 3. Those add up and we get 0. And so that tells me x2 is free. x1 is I times x2. So here is my basis vector for 3 plus 3i. So repeat the process for 3 minus 3i. So nothing really new here, same basic strategy. Take row 2, swap it to row 1 and divide through by 3. Use this 1 to make a 0, multiplying by minus 3i. Okay. And so in that case, I get x2 is free, x1 is minus I x2. And those are my two basis vectors. Alright, in question 4, they want us to list the eigenvalues. And then they're telling us that this is a transformation that has a rotation and a scaling. And they want us to figure out, well, what is the angle and what is the scale factor? Alright, so we form the determinant. where we take a minus lambda I, and we're looking for the determinant, and we're going to set it equal to 0. Alright, so let's see, what do we get? Well, I get 5 square root 3 minus lambda multiplied together minus a minus 25. Well, let's see, 5 times 5 is 25, square root 3 times square root 3 is 3, and 25 times 3 is 75. On the next one, I get a minus 5 square root 3 lambda. I get another one of those, and a lambda squared. And so we get a rather ugly looking characteristic equation. We look at it in terms of the quadratic formula. So here's minus b plus or minus this b squared. Well, let's see, b times b, 10 times 10 is 100. Square root 3 times square root 3 is 3. And 100 times 3 is 300. So 300 minus 400. Extra 0 there. Alright, so the square root of minus 100 is 10i. So divide 2 into each of these, and I get 5 square root 3 plus 5i, and 5 square root 3 minus 5i. The scale factor is the length of the eigenvector, which is the square root of each of my a and b in the complex number squared. So that's just 75 plus 25, so square root of 100, which is 10. And that's my scale factor. If you take the complex number and write that as a and b, in this right triangle, we get the rotation phi. So the tangent of phi is 5 over 5 square root 3. And so phi, or theta, is the inverse tangent of 1 over square root 3, which is pi over 6. All right. In question 5, I'm looking for the eigenvalues again. So form the determinant a minus lambda I. So we actually saw this matrix already once. So lambda squared minus 6 lambda plus 18 is 0. Use the quadratic formula, and we get that the eigenvalues are 3 plus or minus 3i. Alright, to find the length, or r, the scale factor, it's the square root of 3 squared plus 3 squared, so the square root of 18. Square root of 18 can be broken up into 9 times 2, so 3 square root 2. Alright, the tangent of the angle is 3 over 3. So the angle is the inverse tangent of 1, which is pi over 4.